So let's go through some guided practice for hyphen and nuclear notation. We just finished up the lesson on hyphen and nuclear notation, and I want to just remind you, hyphen notation is going to have the symbol for the element. So I'll use an X for that. And then a hyphen that separates the symbol from the mass number. Now remember, the mass number is equal to the sum of the number of protons plus the number of neutrons. So in order to write the hyphen notation for these 5 examples, you're going to need to refer to your periodic table, because that's how you're going to determine which element it is representing. So in the first example, there are 5 protons. Remember, the protons identify the element. So you're going to look here and you see the element with 5 protons is boron. So to start the notation, to write the symbol properly, you're going to put B hyphen, and now you're going to put the mass number. So the mass number is the sum of the protons and the neutrons, and you always want to use the numbers that I give you. Don't go back to the periodic table and take the average mass around it. You got to use the numbers that I give you. Again, this is isotopic notation. So you're going to add your protons to your neutrons. So you're going to add 5 plus 7. And so when you say 5 plus 7, that'll give you 12 for the mass number. So the first example should be B hyphen 12. For number 2, you want to find the element with 15 protons. So the element with 15 protons is phosphorus. So you're going to put the symbol P for phosphorus, hyphen, and now you're going to add your protons to your neutrons. So 15 plus 16 would give you 31 for the mass number. For number 3, 24 protons. So the element with 24 protons, find the atomic number 24. So you see that that's chromium, hyphen, add your 24 to your 28. 24 plus 28 gives you 52. Again, rely on the numbers that I give you here. These are specific isotopes of these elements. Let's look at number 4. We have an atom with 29 protons. Remember, the protons identify your element. So you want to find the atomic number 29, which is copper. Cu, hyphen. Now add your protons to your neutrons. Notice the electrons and the protons are matching for all the ones we've done so far. So these are all atoms, so you don't have to worry about a charge. But to get your mass number, you add your protons to your neutrons. So 29 plus 35 gives you 64. Number 5, 37 protons. So look to your periodic table and find the element that has only 37 protons, and you will see that is rubidium, Rb. So you're going to put the symbol Rb. Notice again, the protons equal the electrons, so it's an atom, no charge needed. You put your hyphen to separate your symbol from the mass number, and now to get your mass number, you add 37 to 48, and that's going to give you 85. So all of those are hyphen notation because there's a hyphen in the notation. All right, now the second type of notation that we learned about today in class was called nuclear notation. Now, for the nuclear notation, you have your symbol for your element. Up top, as a superscript, you will put your mass number. Remember, the mass number is the sum of the protons and the neutrons. Down bottom, and this might not always be there, but we're going to put it there, you put your atomic number, which is always equal to your protons. The protons will identify the element for you. And with this notation, this is the type of notation that you do normally see a charge. So I will say that for this particular example, when you do nuclear notation, always compare protons to electrons to see if there needs to be a charge there. If the protons equal the electrons, there will be no charge because it will be neutral, but if they're different, you have to account for the charge. All right, so again, we have to figure out who it is, so look at your protons. So just like we did a while ago, the atom with 5 protons is boron. So we're going to put for number 1, B. Now, the mass number. The mass number, you're going to add 5 plus 7, and we already did that with the hyphen notation, same numbers we used a while ago. So 5 plus 7 gave us 12, so your top number is going to be 12. In this notation, the bottom number is your atomic number, which is just your protons, so 5. And when you compare your protons to your electrons, you see that they're equal, so there's no charge. So that is an atom of boron. All right, let's take a look at number 2, 15 protons. So just like before, find the element with 15 protons, and it's phosphorus. So we're going to put the symbol P, and we're going to put his atomic number down bottom because the atomic number always goes on bottom. The mass number goes on top, so add your protons to your neutrons. 15 plus 16 gives me 31. And now, if you look, protons equal electrons, so this is neutral. Number 3, 24 protons. If you look to your periodic table, that is chromium. Same as before, protons go down bottom, put your atomic number down bottom. In this notation, atomic number is always down bottom. Up top, you put your mass number, so add your protons to your neutrons, 24 plus 28. And so for that, that's going to give us 52 for your mass number. And again, compare your protons to your electrons. They equal, so it's an atom again. So all 3 of these are atoms. Number 4, 29 protons. So that defines your element. If you look on the periodic table, you'll find that that's copper. The atomic number goes down bottom, 29. Add your protons to your neutrons, 29 plus 35, and that's how you get your top number, which is 64. Now look at this one. If you compare your protons to your electrons, they do not equal. This has 2 less electrons than it does protons. So here's the easiest way to think about this. Think about it. We know that protons have a +1 charge. So that means that inside the nucleus, this atom has positive 29 protons. And in the electron cloud, there are 27 electrons. So that means a negative 27 charge out in the electron cloud. Now look at your math, 29 minus 27. If you do the math on that, you get overall +2 charge. This, since he has lost 2 bad habits, 2 electrons, it got positive by 2. So positive 2 is your charge. Now, you can also write this way, 64 over 29 Cu, and it's okay to put your charge as 2 plus. So you see it written both ways, with the plus sign before the number and the plus sign after for the charge. All right, let's look at the last example, number 5. 37 protons. So again, we did rubidium's hyphen notation a while ago, so we know it's rubidium. We're going to put the atomic number down bottom, 37. The atomic number always goes down bottom. The top number is your protons added to your neutrons, so add your 37 to your 48, and that gives you 85. And now again, compare your protons to your electrons. This has 37 protons and 36 electrons. So it's actually lost 1 electron, which means it has a positive 1 charge. Now, again, if you're writing this notation, it is acceptable to put 85 over 37 RB 1 plus as well. You might also see it written, just so that I don't want you to be confused, you could see it written 85 over 37 RB, and since it's just a magnitude of 1, it is acceptable for it's just a +1 to put just the plus sign, and that's understood as +1. Okay, so I hope that this guided practice helps you understand hyphen and nuclear notation better.